Alright, Assalamualaikum warahmatullahi wabarakatuh. Today we will be presented material characterization and mechanical strength of carbon fiber and titanium composite for aircraft wings. We from 7 group. Let me introduce myself. My name is Otista and my friend Yosua, Reyhan, Zahra, and Fathoni. Alright, let's try it.
Okay, I'm going to explain the introduction section. First, what is material failure? Material failure is the degradation that occurs in metals and or other materials, which can affect in performance, reduce the lifespan of tools, and cause fatal accidents. Material failure can be categorized into several types, such as fatigue failure, corrosion, wear, and overload, and each having different characteristics and mechanisms. In 2012, several Airbus A380 aircraft were found to have cracks in the wing structure. The small cracks were first detected during a routine inspection of a Qantas Airways A380. The main cause was the material fatigue, where repeated pressure cycles during flight caused microcracks to enlarge and develop into significant fractures. In aircraft components, material failure can have fatal consequences. The wing is a very important and influential part. The airplane wing experiences pressure differences on its upper and lower sides, and the types of tests that can be used to analyze an airplane materials are compression tests, tensile tests, bending tests, composition tests, and the one that we're going to analyze is microscopic tests.
Alright, to objectively have to determine the effect of structural strength before and after testing and know safety and reliability of tensile test and SAM.
Okay, now we move into basic theory. The first we will explain about composites. Composites are materials resulting from the union of two or more different materials, where this new material has better physical and mechanical properties than the original properties of each constituent material. Composites can be classified based on their matrix material, namely the first is polymer matrix composite or PMC, and the second is metal matrix composites or MMC, and the third is ceramic matrix composite or CMC. Okay, next, we will explain about carbon fiber. Carbon fiber has become a popular reinforcement for metal matrix composite as it offers an outstanding combination of high strength, high stiffness, lightweight, and good thermal conductivity. Size of carbon fiber will also have an impact on the tensile properties and corrosion resistance of aluminum MMC. MMCs with smaller carbon fibers show better tensile strength and corrosion resistance than MMCs with larger carbon fibers. Okay. The next is titanium. Titanium is a transition metal known for its strength and resistance to corrosion. Titanium is used as an aircraft wing material for several reasons, including the first is high strength and strength to weight ratio, second is good corrosion resistance, the third is resistant to high temperature. Okay. Next one is epoxy resin. Epoxy resin is a type of thermoset resin that is widely used in the aviation industry, including aircraft wing materials. Epoxy resin has several properties that make it ideal for application in the aviation industry, such as high tensile and compressive strength, high stiffness, corrosion resistance from seawater and chemicals. Resins are commonly used in combination with reinforcing fibers, such as carbon fiber or glass fiber to make composites. These composites have higher strength and stiffness than epoxy resin alone and are also lighter. Okay, the next is tensile test. Tensile testing is one of the most commonly used mechanical tests to evaluate the material properties of aircraft wings. This test is performed by applying a tensile force to a material specimen until it breaks, and measuring various parameters such as tensile strength, elastic modulus, and strain. The tensile test result can be used to assess the suitability of the material for use in aircraft wing construction. Okay. The last is scanning electron microscope or SEM. SEM is an electron microscope that produces high-resolution image of sample surface. It uses a high-energy electron beam that is scanned over the sample surface to produce detailed image. SEM can achieve resolution down to a few nanometers, which make it ideal for studying the micro and nanostructure.
Next, alright, the methodology. We choose tensile strength and scanning electron microscope or SEM. Alright, the raw material is we use titanium, carbon, and resin epoxy. The function of tensile testing on composite material determines in strength and durability of the material, while SEM testing analyzes the microstructure to understand particle topology and distribution, helping to diagnose failure and improving material design. So, for the tensile test, the tensile test step began with prepare the specimen according to standard. Then installing in on the specimen at constant speed will sensor measure force and stretch the recorded data for the strain stress curve to determine mechanical properties such as tensile strength and electric modulus. For the scanning electron microscope or SEM, the step for using a scanning electron microscope SEM include sample preparation and coating, placement in a vacuum chamber, and placement to parameter and shooting beam, and that's it.
Tensile test. Based on the first table, the highest tensile strength of the carbon fiber reinforced composite reached 615 MPa. In the second table, the average tensile strength of the carbon fiber reinforced composite reached 265 MPa. And the mixed composite of the carbon fiber and a glass showed a decrease in value, but the decrease was not significant due to the high mechanical properties of carbon fiber. From the tensile test result of both tables, it can be concluded the carbon fiber is a reinforcement with excellent mechanical properties, making it suitable for replacing materials that require high strength.
Okay, for the second discussion is scanning electron microscopy or SEM test is conducted to see the fractured surface of the composite and also to see the structure between the carbon fiber and the matrix. The sample used for the SEM test were the samples with the high and low strengths of the tensile test samples on the carbon fiber composite. From the image above, it can be explained that for the tensile test, the lowest strength is shown in figure 1 with a fiber volume fraction of 23 pas 18% of 58 megapascal, where the highest value is bound in a fiber volume fraction of 40%, which is 135 megapascal, namely in picture 2 or figure 2. In the result of the SEM carbon fiber test, it can be seen that the specimen with the lowest test value has a smaller number of fibers, where the composite is more dominated by the matrix, while the test specimen with the highest value has a large number of fibers spread throughout the composite. The number of fiber is what affects the strength of the composite. Okay, and the end of the presentation is the conclusion. The conclusion of comparing the composition of aluminum and titanium with carbon fiber and titanium composite shows that carbon fiber and titanium composite are superior in various aspects. The tensile test results show that carbon fiber and titanium composite have higher tensile strength and modulus of elasticity than aluminum and titanium, making them more suitable for applications that require light but strong materials. As in testing, we feel that the carbon fiber and titanium composite have a more homogeneous microstructure and better bonding between components, which contributes to superior mechanical performance. While aluminum and titanium are still good materials, carbon fiber and titanium composite offer advantage in application requiring a combination of high strength, lightness, and structural. More or less, we apologize if there are any wrong word in this presentation. That's all from us, and thank you very much.